Okay, good morning all of you. Today now going to discussing about the electric flux. Electric flux. Already we know that electrical field. Okay, electrical field means the space around the electric charge where it is can be felt by the another charge is known as a electrical field. Here now going to explain the electric flux. Electric flux means the number of electric field lines passing, number of field lines crossing given area kept in normal to the electric field. Electric field is known as electric flux. Okay, the number of electrical field lines crossing given area kept in a normal to the electric field is known as a electric flux. For example, already you know that electrical field lines starting from the positive charge end on the negative charge. For example, ceiling on our room, that is taken as the positive charge, have a earth is the negative charge, floor is the negative charge. The electrical field lines passing from the ceiling to beam, that is a ceiling to floor. At that time, for example, this is a place. The number of field lines crossing the given area, okay, as well as in this case have a rotated. Okay, this is the less number of electrical field lines are passing compared to the first case. This means, for example, here is the positive charge. This is the positive charge. These positive charge electrical field lines passing always outward direction. Okay, this is the positive charge. This positive charge is create the electrical field around it. Now, for example, here is a place with the charge area. Here is also placed same like that. Okay, this is the area A. This is the area B. Okay, compared to area B and A, the area A is the number of lines is the maximum. For example, 1, 2, 3, 4 lines. Here is only 3 lines. This means that is a electric flux. Region A is more than the region B. Okay, all of you understand. Here a number of electrical field lines crossing a given area kept normal to the electrical field. Here, for example, this is a electrical field lines. This one, the area is a place perpendicular to the field. That is a electrical flux is maximum. Suppose another condition, you have same as well as the electrical field this direction, but this area is placed parallel to the field at that time, that is equal to electrical flux is equal to 0. Electrical flux is equal to 0. Okay, now for example, two types of electrical fields are there. Electric fields. One is uniform electrical field. Uniform electric field. Uniform electric field, and as well as the non-uniform electric field. Non-uniform electrical field. In this condition, find the electrical flux. That is a two types of the electrical field: uniform electrical field and non-uniform. Uniform electrical field, to find the electrical flux. For example, this is the electrical field length. That is a uniform. Uniform means that is a both magnitude and direction is the same. That is a kept in the normal. That is a electric flux phi is equal to EA cos theta. EA cos theta. Why that is a EA cos theta means that is a electric flux simply defined as a electric flux simply defined as scalar product of E and A. E and A. Scalar product of E means electrical field, A means area. A, how much electrical field linked with the surface. Okay, now that is a simply defined as a scalar product of electrical field E and area A. Same as well as the non-uniform electrical field or later curved surface. For example, you have taken for the curved surface. Okay, here is a moving this direction, non-uniform electrical field, this direction. Here taken as the area element, that is the ds. Area element is the, here is also area element, that is a ds. Area element is the ds. Or here later or that is equal to phi is equal to E S cos theta. E S cos theta. For example, here area element, that is a angle theta. Here is the electrical field E. Now here write the d phi is equal to E d S cos theta. E d S cos theta. Now again rewrite this equation. D phi is equal to E dot ds. E dot ds. That is equal to phi. Total flux is equal to integration of the only small flux. That is equal to phi is equal to surface integral of, that is equal to E dot ds. E dot ds. This equation is used for the uniform electrical field of electric flux. This equation is a non-uniform electrical field of a electric flux. Okay, understand? Now, in this condition, are you understand all of it? That is a electric flux means already explained the number of electrical field lines crossing given area kept in normal to the electrical field is known as the electrical flux. What is the use of the electric flux? What is the use of the electric flux? Okay, electric flux is measure of flow of electric field through the surface. Okay, what is the use of the electric flux? The electrical flux is a measure the flow of electrical field through the surface. Okay, now electrical flux is a maybe positive, negative or zero. Okay, this is the electrical flux in a uniform magnetic field. This one is the electrical flux in a non-uniform electric field. Okay, now Okay, already one point already explained, that is a simply defined electric flux, simply defined as a scalar product of electrical field and surface, electrical field and area. Okay, now the electric flux is maybe positive, comma negative and zero. Maybe positive, negative and zero. Okay, the electrical flux may be positive, negative or zero. In this condition, for example, already we know that here is the, for example, surface of the area is treated as the vector quantity. This is the surface of the area. Here is a taken for the area element is the ds. ds is a represented the vector. Here is also n. A, because of this is the surface. This surface is observed this light. A, both magnitude is there as well as the direction is there. So area is treated as the vector quantity. For example, here is also is there. This one is the direction, this is the magnitude. Both magnitude and direction is there. So area is taken as the vector quantity. So here is the three conditions. For example, this is the area vector, that is n, and the second one same area vector n cap, and as well as the third one is the area vector n, and finally fourth one, that is the area vector n cap. Okay, for example, the electrical field lines passing this line, this is a electrical field lines passing, this is the angle theta. In this condition, flux phi is equal to Es cos theta. Okay, in this condition, the electrical field lines passing parallel to the area element, that is equal, phi is equal to Es cos 0. Both of it parallel. So that is equal, phi is equal to Es cos 0 means 1. That is equal, flux is equal to Es. Okay, in this condition, the electrical field lines passing through perpendicular to the area element, that is a flux is equal to Es cos 90, that is equal to Es cos 90 means that is a 0, that is a total flux is equal to 0. Okay, next, that is the electrical field. The electrical field and area element is a opposite direction. Theta is equal to 180 degrees. That is a flux is equal to Es cos 180. Now that is equal to, phi is equal to Es minus 1. That is equal to, phi is equal to minus Es. This is the flux is negative. Okay, this is the four conditions. Okay, all of you understand? Here, so many numbers are thinking. The electrical field is passing through the perpendicular, that is taken for the 90. You are considering for the area element. Area element is a n. Okay, area element and electrical field is a same direction, parallel. That is a theta is equal to 0. Theta is equal to 0 degrees. Here is a, you are thinking that is a passing through the perpendicular. This area element and electrical field is the perpendicular. The theta is equal to 90 degrees. Okay. Thank you. Now next one. Next one is the, for example, in a closed surface, this is the positive charge, closed surface, inside the positive charges is there. Okay, these positive charges, the electrical field is a always outward direction, always outward direction. This, in this case, the flux is taken as positive. Another one, that is a, for example, in this case, here is the negative charge. Negative charge means the electrical field ends always inward direction, always in the inward direction. In this case, the flux is taken as negative. Now, for example, another case is there, that is a, another case, that is in this closed surface is there. Here is the charge cube, here is a passing. Okay, this electrical flux, already the flux is taken as the positive, outward direction is the positive. Okay, here is the positive, here is the inward direction, this is the inward direction, is taken as the negative. Okay, total, for example, total electrical flux is equal to total electrical flux. This is the negative, this is the positive, both of you cancel, negative positive cancel. The total flux is equal to 0. The total flux is equal to 0. Same, another example. For example, one open pipe is there. Here, electrical field lines are passing in this situation. Okay. Here, okay, 3 conditions are given, that is equal to A1, this is the A2, this is the A3, this is also A3. Okay, flux through A1 is equal to, A1 means the flux is a inward direction, so is taken as the negative. Flux through A2, that is equal to, flux is a coming outward direction means already is taken as the positive. A3 means that is equal flux through A3, this is a not passing through the any surface area, so flux is equal to 0. Okay, thank you all of you.